We have used it in the PHIUS certification program, and in this webinar we will see how to use this tool with more precision. In general, shading simulation techniques address the influence of solar radiation on the building. These are fundamental to determine if our models meet particular environmental targets, indoor comfort standards, and potential for views. For site shading, the geometry that we model depends on the context variables. In every project, the context is different. Then we want to know effective ways to model it. Therefore, we will see 4 key aspects related to site shading in this webinar. This review what has changed in Buffy Passive in relation to site shading, how you can represent site shading elements, what possibilities bring us an updated PHIUS Pathfinder protocol in compliance with Buffy Passive, and what are the differences between the new site shading methods. First, I talk about how site shading is accounted in our certification program. If we go through the solar protection tab in Buffy Passive, we will see several shading elements: landscape obstructions, overhangs, other shading fractions, and sunscreen devices. In our models, shading reductions are calculated from these elements. Those landscape obstructions and other shading fractions account for site elements. Previously, we had to enter landscape obstructions numerically for each transparent component. With Buffy Passive version 3.2, we can hit the button Calculate Buffy Shading in the General tab to calculate this obstruction from our 3D geometry. However, in the case of other shading fractions, we still need to value or to enter these values numerically. Here we can see the difference between the 2015 and the 2018 certificate criteria. In 2015, landscape obstructions and other shading fractions are obtained from the PHIUS Pathfinder protocol. In 2018, just other shading reduction factors are obtained from the PHIUS Pathfinder protocol. In this sense, the methodology brings us new modeling possibilities. Particularly, we see 2 key aspects at PHIUS. First, how we can have a more accurate representation of landscape obstructions. And second, how a geometrical component can represent seasonal shading within Buffy. Since we want to export our geometry from SketchUp into Buffy Passive, there are particular steps that we need to follow when modeling site shading elements. This to make sure we use the Buffy shading methodology in a correct way. As a first step, we recommend simple modeling of the adjacent structures. Before importing your geometry into Buffy Passive, you must edit in SketchUp. The less polygons, the better. In fact, simple surfaces or volumes import faster, such as the case of this feasibility study in Canada, a residential building, when we got the SketchUp model with tons of information, with tons of polygons, and before importing it into Buffy, we had to leave just the polygons that describe the contours of the buildings. As a second step, we need to make sure that our shading calculation is precise. To be there, you need to enter the project geometry and not the whole geometry in the center. In SketchUp, your building must stand on the intersection of the X, Y, and Z axis. Also, it helps you to work more efficiently in PHIUS. To manage this, you need to create two fake components in SketchUp. These are circles that cover all the geometry you placed, and these components are located at the same distance from the ground level when you create them in SketchUp, one above the project and one below. And to subtract them from the shading calculation in Buffy, we changed their type from opaque into transparent. I want to show you a video with this information. So here we see that we relocate our project. Oops. We relocate our project in the SketchUp space. We add some adjacent structures, and when we import into Buffy, the geometry is not in the center, which doesn't give a precise use of the new Buffy shading methodology. This problem is more evident when we add a taller structure like this building, and our project, our condition zone, is far away from the horizon, and it doesn't help to work on adding features to the geometry. Therefore, what we do is we create two components, one above and one below the project. These are these two components that we see in this elevation. These components look like this. And when you have these components into Buffy, you just turn them from transparent to openings, and in this way your project is exactly located in the origin to be calculated precisely with the new Buffy shading methodology. In the old methodology, we are going to talk now about landscape obstructions. These were entered numerically. Now we see that the amount of work that we had to do with the old methodology, since every window had a value for height and distance of landscape obstruction. In buildings with several stories, it was more complicated, as we see in this image. With the new methodology, you don't need to enter these obstructions, because these rely on the context geometry you import. In the certification reviews, we see different approaches to model landscape obstructions, and in the next slide we will see some examples on this. Some projects model now the urban context. The solar view factor is determined predominantly by adjacent structures. This is particularly useful in buildings with dense urban locations, such as this project in New York, where all obstructions from the side are modeled. So we see here two screenshots from different reviews where we recommend the team to model the whole block, since this building was in a dense urban location. Some projects model the rural context. In this case, topography influences the solar axis to the building. To account for topography, we model it through simple planes, such as this house located beside a valley in Utah, where the topography obstructions are represented. Some projects model external elements at the ground level. We account for objects such as fences and light wells. These components might shade windows at the basement and the ground floors, particularly in periods of lower solar angles. This is also a case in Utah house, and besides the wood fence, light wells around the house were also modeled. Some projects model shading elements that are not part of the building. We can account for canopies or sunroom structures. This is possible now with the new shading methodology. We could not represent that before. And this is the case of this house, where a canopy on the south and a gallery on the north are modeled. Some projects model trees. These are represented through opaque surface components. To be precise, pay attention to the height and the shape of the tree and its crown. You could also give the sense of volume by using two perpendicular surfaces, such as the case of this building. We see some trees model on the south, and this shape is the shape that was proposed in the landscape design. Also, some projects model rows of trees. We can project continuous vegetation on a single plane. To do this, the component must describe branching patterns and crown shapes. The objective is to model an estimated outline of the tree crowns, such as this house, where each plot is defined by rows of trees. Then a perimeter component is modeled. Let's go to the old methodology for a while. In the past, we used the PHIUS Plus 2015 Pathfinder protocol to calculate side shading inputs. This tool gave us the values for height and distance of landscape obstruction for north, east, and west views. In that case, we overlap sky dome images with angle estimator charts. In each orientation, images and charts were analyzed in quadrants. Then in each quadrant, we track a shading angle and weight it. To have just one input, we average these angles. And finally, as a distance of landscape obstruction, we use an arbitrary horizontal distance of 100 feet. And to calculate the height of the object, we multiply the horizontal distance by the tangent of our average angle. Also, we use the PHIUS Plus 2015 protocol to calculate other shading fractions. For south views, we analyze the sun path manually. So we superimpose the sky dome image to the grid of months and hours to decide which half hours were blocked, and adding up weighting factors for the non-block half hours. With this, we were able to get solar exposure percentage per month. For each month, we repeat this process until we average the months of November to April to get the winter reduction factor, and the months from May to October to get the summer reduction factor. With the new methodology, this protocol is still in use for reduction fractions. However, based on the new movie shading methodology, we have been working on updates on the Pathfinder protocol regarding how geometry also accounts for other shading reduction fractions. We see similar examples, or a similar example in this case, where from sky dome images a continuous opaque element is modeled. It accounts for obstruction but not for seasonal shading. In fact, to take advantage of the new movie passive shading, we target to calculate other reduction factors from an import geometry. So you don't need to enter these values numerically. In the next slides, I will show this process. We can use sky dome images to generate a shading component for movie passive. In a new calculator, we overlap these images with angle estimator charts to generate the data on the width, height, and elevation angles from all side shading elements. These data are transformed into a component that represents the horizon geometry. To track shading angles, we now use the dual pathfinder protocol. This is an Excel spreadsheet that contains information for summer and for winter shading. For each direction, we track angles in a similar way. First, we need to define a field of extension. This is the distance between our project and the horizon geometry. To calculate it, we take the longest side in our building and multiply it by a radius with a default of 10. Then, we track shading angles in each direction. In the calculator, there is a tab for north, south, east, and west. In each tab, there is a table and a half circumference graph. The table has 3 columns. The first column contains orientation angles, each 10 degrees. In the graph, the white ring shows these degrees. For the north orientation, we can see angles from 270 to 90 degrees, where the north is located at 360 degrees at the top. Now we need to import the sky dome images from the corresponding orientation. This helps us to track the shading angles. To get there, we need to scale, rotate, and align the sky dome image with your graph. As you can see, we just focus on a 100-degree range per orientation. We do not track angles from lighter gray rows, since we want to avoid distorted or discontinuous sky dome images. In the next step, we trace winter shading angles. In this case, we just track coniferous trees and disregard deciduous. Each 10 degrees we observe at the eyeball average angles from the sky dome image, and as we type their value in the second column of our table, we make up the obstruction line for winter. This is the yellow line we observe at the table. When we move into summer tracking, we repeat this process. In this case, we track deciduous and coniferous trees. Sometimes the pathfinder images are taken in winter, where there are no leaves on trees. So, to account on them, we need to estimate a tree contour from the observed branches. The summer angles are entered into the third column of the table, and these make up the obstruction line for winter. This is the red line we observe at the table. At the end, we have summer and winter obstruction lines for each one of the 4 orientations. These are collected in 2 tabs on the calculator, the summer import tab and the winter import tab. Each tab contains a list with 3 values. First, the orientation angles we use to track shading angles. Second, the horizontal distance we calculate as a field of extension. And third, the vertical distance, that is the tangent of the shading angles we enter, multiplied by the horizontal distance. We reach to the final steps in this process when we get this summary, this table, that contains data on orientation, distance, and height. And now we need, for summer import and for the winter import tabs, we need to extract the data from those tabs, and we need to save it into a CSV file. The CSV is a comma-separated value file in Excel, and we are going to use the CSV from summer and the CSV for winter in the next step in SketchUp. Before that, let's see another video that shows the process of the dual pathfinder protocol. So here we see the calculator. We see the different tabs. This is the shading summary tab. When we enter the multiplier and the radius of the building, we see here our house and the longest side, that is 95 feet. Then we go to the tab of the north orientation. We see the orientation degrees and the columns for winter and summer shading angles. In this case, we have the graph, and behind the graph, we have our sky dome image. And this process of tracking allows us to have a yellow line for winter and a yellow obstruction line, red obstruction line for summer. Same happens in the south and the east and in the west. In this case, for this project, we also have an app that was showing us sun elevation angles. In the summary, once we enter all these values, we see this calculation of the orientation, the distance, and the height for winter and the height for summer. Then, if we go to the winter import tab, we will see a list of values, and this is the list of values that we are going to save as CSV files. So once we save these CSV files, we are going to work with that into SketchUp. We will see that in a moment. Back into the geometry generation, we need to upload the CSV file into the SketchUp program. With this, we will translate a numerical input into a geometrical output. For this process, we use an extension called Solar Pathfinder. This extension was developed by Skylar Swinford. And once this extension is installed into SketchUp, it appears a tab with this funny icon. Clicking at this icon allows you to import the CSV file or the list that we create in the Excel calculator, and then we see a generated component in our screen. That are these components that are on the right for winter and for summer. We insert the geometry of our project into the horizon components to work with them in Buffy Passive. We need to assign properties for each one of these components in a particular way. In the winter horizon, inner and outer sides are assigned as outer air, while in the summer horizon, the inner side is assigned as outer air and the outer side is assigned as ground. Both horizons must be placed in the origin as the project's geometry, and we can see also a video. In a video, we can see this in a more explanatory way. We begin SketchUp, so we go to the extension manager. In the extension manager, we check that the Solar Pathfinder extension is installed. If it doesn't appear, we use the toolbars to find it. It's there, it's Solar Pathfinder. And we need to get rid of this component, the Woman component, the scale component. And the first step that we do is we go into our folder and we select the summer list. We import it and we import also the winter list that is here. So we see now the two horizon components, the winter and the summer component. And the following step consists into create two layers, the layer for summer and the layer for winter. We assign the first component to summer and the second component to winter. And then we assign the exploded to delete the bottom part, since we don't have it to have a conflict with the project geometry. We do the same for the winter. And as a final step, we need to assign the properties for Buffy passive. So for the summer, we add these properties. We turn the layer off, and for the winter, we assign the properties that we previously saw. For the inner side, outer air, and for the other side, also outer air. So once we have the properties, we can add our house, our project geometry that is on the origin in the center. And we see that the horizon geometry goes around this project. It has an appendix there that it allows the geometry to be located in the origin in Buffy, and we will see now this through our slides. Let me close here. I hope you see that. In Buffy, once we import the generated geometry, we must create 3 cases. We call case 1 the summer shading test, we call case 2 the winter shading test, and we call case 3 winter shading test plus summer reduction factors. In the following slides, we will see this in detail. First, we have the summer shading test. In this case, both horizon and shading components are opaque. Results of cooling demand and cooling load are more accurate in this case. Then we have a copy of the case 1, and we name it as winter shading test. In this case, the summer horizon geometry needs to be hidden. So we change its type from opaque to opening. And with this, we just account in Buffy for the winter shading geometry. Results on heating demand and heating load are more accurate in this case. Then we copy case 2 and name it as winter shading test plus summer reduction fractions. This is the case PHIUS reviews for pre-certification. It integrates results from case 1 and case 2. And in case 3, we need to reach the results of cooling demand and cooling load from the first case. To get there, we modify the entry of other shading summer fraction of solar exposure in Buffy. Since we cannot add shading, but we can subtract it, so we enter a value less than 1 for other shading summer fractions of solar exposure, and this value is applied to all windows in the project. And after a couple of attempts, you reach the cooling demand and the cooling load from the case 1, and those results are the ones that we use for pre-certification. Let's see this also through a video. These are the geometries on the way it looks in Buffy passive. We see that these are at the ground level in our project. So we have this first case that is the summer shading test. We copy it and we name the case 2 winter shading test. We see now that we are gonna change the type from opaque into transparent. It looks in this way. So we have now case 1 and case 2. And we duplicate case 2 or copy case 2 and name it winter shading test plus summer shading fractions. And the process is that we go to case 1. We can make a screenshot of the results. We see we want to take into account these results.
I need a better angle.
And now, in case 3, we will use the cooling demand and the cooling load of case 1 as targets. So we go to the first transparent component, we go to the entry of other shading summer fraction of solar exposures, and we start to reduce shading. We test 0.8. We go to the assign data bottom, and we select that, and to all transparent components of case 3, we perform this change. So we say here just for all, and we can now see a new sort of results where the important thing is to achieve the results from case 1 of cooling demand and cooling load. It was a little fast, so let's try it again. We are gonna change now to 0.77 the summer fractions for all components in case 3. And now we can see that we reach 0.2 of cooling demand, such as 0.21 in case 1. So this is the process that we work in Buffy to get one case for unification. So going back to our slide presentation, we will see now the final part of this webinar, where we want to know more about the incidence of site shading. With the new shading methodology, we have seen many projects that model context, and currently at PHIUS we are studying the sensitivity of these methods. We want to give teams more guidance on this topic. In this sense, we show today a comparative test that we perform at PHIUS. To know more about each shading method, we use a case study. It is a single family house. Its context is modeled using 3D volumes and using the horizon geometry methods. And we want to see what is the influence of site shading on demands and loads. Results allow us to see the influence of orientation, distance, and size of neighboring buildings. As an experiment, we insert a single family house into a real context. This context is a small park close to PHIUS offices in Chicago. From these images, we see this dense location in the loop that is surrounded by buildings. On the east and west, we have mid-rise, and on the north and south, we have high-rise observed from these screenshots. Our two-story house that is here is inserted into one of the corners of this park. We try to keep the distance from the neighbors. The house has windows on all directions and a small canopy on the south. Then we build the site shading geometries. In the first method, we use Google Earth images to model the 3D volumes of surrounding buildings. While for the second method, we use SkyDome images taken at the site and enter them in the dual Pathfinder protocol that we saw in Excel. Please see that we don't take into account the existing trees in the park. We just take into account the adjacent volumes. As you can see from these SketchUp images, our project is at the origin. Indeed, we see the fake components we saw before, or we use these components for the 2D and 3D volume. We can see part of this component on the left. And in the horizon geometry method, we place the component at the ground level, and as I mentioned before, thanks to this appendix that is automatically added with the Pathfinder protocol, this geometry is also at the ground level. In the next slides, we will see a comparison of both methods, observing the field of extension, or how much side context you can add, or you should add to a project. Here we see 3D adjacent volumes in different colors: green, gray, and yellow. These colors represent their proximity to the house. We have, on gray, structures on a radius of 100 feet. On green, structures on a radius of 360 feet. And on yellow, structures on a radius of 800 feet. To test different fields of extension, we assign to these values different properties in SketchUp. With this, we can turn off volumes and observe results for each one of these three cases. For the horizon geometry method, we also have three cases with the same radiuses. To generate our geometry, we use the dual Pathfinder protocol, and we track shading angle from our sky dome images taken at the site. Also, through the calculator, we can scale up the horizon components and have similar cases as the 3D volumes. At 100 feet, we include in the calculation mid-rise buildings around the park. These are showing the Pathfinder images that we took. At 360 feet, we add into the calculation more mid-rise and one high-rise building to the north. This is not shown in the Pathfinder images we collect. Finally, at 800 feet, we add into the calculation three additional high-rise, two high-rises on the west and one high-rise in the east, and those high-rises on the west are in fact shown in our Pathfinder images. Now we summarize the results from our multi-passive models. As you can see, we find relatively similar results in both methods. First, let's look at results on heating. We observe less heating demands with the 3D volumes method. Results indicate less shading accounted with the 3D horizon geometry method. The horizon component seems to block more solar axis, influencing higher heating demands. And in the case of cooling, we see that the 3D volumes method has slightly higher values. It happens in the first two comparisons, but not in the third. And we think that is because for the third case, a larger extension of the horizon geometry allow more gains. Then, in multi-passive, we can go to the passive house verification report. It includes information of shading reduction factors for each orientation. Here we can see the solar axis for the heating season. Results indicate that the 3D volumes method has a larger solar exposure or less shading. We observe a larger difference on the west direction, and it seems a consequence of inaccurate representation in our model buildings. In reality, these volumes might have a different size or shape or location, and the SkyDome images can represent better those, and our observation from Google images perhaps are not that precise. Then, let me finish with saying that in this webinar, we have seen several aspects related to site shading. And from there, we can conclude that first, we see that the speed and precision are improved with the new changes in Woofy Passive. This is intended to make easier your work through the PHIUS certification process and bring more resolution on the side shading calculation. Already we see some projects with interesting approaches. Therefore, at PHIUS, we continue exploring how to take more advantage from this methodology. Second, we see now an updated Pathfinder protocol, and with this, PHIUS aims to capture more information from skydome images to account not just for landscape obstructions, but also for seasonal shading. With this, the geometry of the project and its context are calculated into Woofy Passive, and there is no need to add numeric values. Third, we compare results between side shading methods. Cases on 3D volumes and the horizon geometry have similar results. And regarding this, PHIUS works on further experimentation on the field extension. And a comparison of results in suburban environments, we need also to go into this sort of experimentation. Finally, these updates help you to determine the potential benefit of shading from adjacent structures. Through the 3D volumes of the horizon geometry, you can observe the influence of side shading in your project, either to decrease summer energy requirements or the loss of warming influences which increase demands during winter. With this, we finish today's webinar. I hope this opened new possibilities in your work. We also have finished a new tutorial that is called Woofy Plugin. We will upload that tutorial in our website. I'm just going to show you quickly how to use this tool, this tutorial. So it's going to be available, and it contains part of the information that we have seen today, some specifications about the document and screenshots that can guide you on how to make the transition from SketchUp into Woofy. What do you need to model? What is the topic with windows? How to add shading elements and not have conflicts, the aspect that we saw about centering geometry, how to represent curved elements, how to make a faster modeling in SketchUp in tall buildings. So this document will be available at our website. And with that, I'm looking forward to hear from you regarding new developments in side shading. Your questions or via email are welcome. Thanks for your attention. Sorry for my microphone. I hope it didn't affect the quality of your audio. And if there are some questions, I will be glad to answer them. Thank you. There is a question that says when it will be available. So I guess it's talking about the webinar, so the document. So this document will be, I think this week we will upload it with Chris in the documents and protocols, so you can see more about the process that we discussed today. Chris, I don't know if you get.
Yes, there's a couple of questions. They're in the chat. They're scrolling by pretty fast. But see if I can grab some here. Let's see, there was one by Sarah, says that I have a question about the utility of the little circle above and below and how to size them.
Right, so let's go back to that. See this screenshot here. So we can see here the fake components. These two components, the idea is that one of these two components, either the one above or the one below, need to cover the whole geometry of the project and the site shading. And they need to be with a distance from the ground in a way that they don't interfere with the project's geometry. So that is the main recommendation about this, how to size these components. And see other questions.
I'm running low on ammo.
If he doesn't mention it, it might be worth mentioning that Wi-Fi users need to know. No, attach SketchUp. This is not a question. I think there are good feedback through the SketchUp process. Thank you for it, for Gali and Bob, that are sending new more content from this. We will update it through emails, or I will follow up responses. Sarah. Jacob is asking me if I could show the PHIUS CEO number. Chris, I don't really know what is this number.
This should be the CEU code. Was this created for you? Did Mike create that for you? Do you have a slide of that?
So I will also follow up with this number since I'm not. So what is there is another question for Jonathan. Aaron says, before that, Aaron says, lots of information here. Thanks for the presentation. Jonathan asks, what is the height of the circles from the origin? So the idea is to have, so these circles don't really touch, like if you have a two-story building, you try to make a distance from the circle. The circles are not accounted in the shading calculation. These circles are modeled just to make sure that once you import your geometry into Woofy, the project geometry locates at the ground level. So it's not that important that, as James Ortega, my colleague, says, we will share the code of the webinar in the following email. Is there any more questions? Perhaps I'm going through the question to the chat now. So Carmel asks, is there any specific type of tree modeling you are accepting for the 2D, 3D method, or do any of the types you mentioned work? So what we want to know, when you're using the 2D or 3D method, we want abstractions of the trees. And as I mentioned, the idea is to represent us in an abstract way the size of the tree and the shape of its crown. If there are more, it will be ideal to show this development. I will go to that slide. Here.
You'll be completely exposed out there.
80 floors and a rooftop is a long way down.
This slide. So we see like these sort of simple abstractions, but in the case of trees, like in this school, the team had the landscape plan, and in this plan they were specifying the trees that they were gonna use, so they did their best to represent those, but also you could add or to generate a perpendicular plane, and then you can count not just for the silhouette, but also for some sort of volume. I have seen other projects that try to import the whole volume through surfaces. That also works. I don't have a slide to show you, but that can also be used. Thanks for James. The code, the PHIUS CPHC CEU code is the 05572.
And please remember, this code will actually be emailed to you in a follow-up email. So if you weren't able to get it here, we'll be providing it to you via email. And we'll also have the link for you to be able to self-report in the email as well.
Right. Thanks, Chris. So thank you very much to all of you. Thanks for your attention. And if there are no further questions, so we can conclude this PHIUS webinar, please send us your feedback. We will be glad to hear from you. There is a final question of Chris that asks where we can get the SketchUp plugin. So we also gonna upload it into the website. We are working in some additions to this plugin to make a faster process. So we will upload it with the new Pathfinder protocol and the Excel file that we saw in this presentation. So we will also be updating it soon. So finally, just to finish, my email for further questions is apinson@phius.org. This is a work that from the certification team. So also thanks to James and to Lisa for the help, and thank Christopher for your assistance today with Zoom. Thanks, everyone. Have a good one.